Page 5 of exponentials. First of all, it asks us to show how the book uses this rule to show that a to the half equals the square root of a, and a to the third is equal to the cube root of a. Let's say that we want to show that a to the first is equal to a to some power times a to some power, and these two are the same power. Okay, so if this is true and there is an x which satisfies this, then these x's added together should give us 1, right? So let's say it's 1 equals x plus x, which is also 2x, right? It turns out that in this case, x is equal to a half. Okay, so actually what we're saying here is that a to the first is equal to a to the 1/2 times a to the 1/2, right? But we know that if we have a to the first, that's the same as a, right? And a divided into two factors which are the same is square root of a times square root of a. So we've just shown that square root of a is actually the same as a to the 1/2. We can show the same thing with a to the 1/3. Okay, we can do the same thing. We can say a to the first is equal to a to the y times a to the y times a to the y, and in this case, 1 is equal to y plus y, which is equal to 3y. So y is equal to 1/3, right? So actually, a to the first is equal to a to the 1/3 times a to the 1/3 times a to the 1/3. But we already know that a to the first is equal to a, and a, if you multiply the same thing 3 times together to get a, that would have to be the cube root of a times the cube root of a times the cube root of a. So we've just shown that the cube root of a is actually a to the 1/3. Okay? All right. Next it says that there are two other rules. The general rule saying that, well, if you have a to the 1 over some number, like let's say 10, that is equal to the 10th root of a. Okay? So whenever you have a number n here in the denominator of this 1 over fraction, then that is the same as the nth root of a. And if you have, more generally, a rational number, a rational ratio here, m over n, m and n being whole numbers, then you can rewrite it as a to the m, and then you take the nth root of that. Okay, makes sense? Because a to the m over n is equal to a to the m to the 1/nth power, which is equal to the nth root of a to the m. Okay? All right. Right as a single power of 2. So first I start out with 2 to the 5th root of 2. So the 5th root of 2 would be 2 to the 1/5, right? We just learned that. In this case, we have 1 over the 5th root of 2. So that would be 2 to the negative 1/5. Oh, by the way, it says to do just the odd ones, a, c, and e, so we don't need to do b, d, etc. So 2 square root of 2 is equal to 2 to the first times 2 to the 1/2. That is equal to 2 to the 3/2, right? What about e? 1 over the cube root of 2. So that would be 1 over 2 to the 1/3, which is equal to 2 to the negative 1/3. Let's see, g. 4 over the square root of 2. So that would be 2 squared divided by 2 to the 1/2, which is equal to 2 to the 2 minus 1/2, which is equal to 2 to the 3/2. 1 over cube root of 16 is 1 over, 16 is 2 to the 4th cube root, which is equal to 1 over 2 to the 4/3, which is equal to 2 to the negative 4/3. Okay, now we're doing A, C, and E. The cube root of 3 is written as 3 to the 1/3. C, 3 to the 4th root of 2 is equal to 3 to the 1/4. E is 1 over 9 square root of 3 is equal to 1 over 3 squared times 3 to the 1/2, which is equal to 1 over 3 to the 2 plus 1/2, which would be 5/2. And then it's in the denominator, so we're going to put it in the numerator. We're going to say that's 3 to the negative 5/2. All right. All right, without a calculator, write in the simplest rational form. So here we have 8 to the 4/3. So if we have 8 to the 4/3, we can take the 8 and we can factor it into 2. So instead of 8, we're going to put 2 cubed, and that's to the 4/3 power. Now, it's a exponent to the exponent, so you can multiply those together. 3 times 4/3 is going to give you 4, so that's 2 to the 4th, and that gives you 16, right? What about the next one? 27 to the negative 2/3. 27 can be rewritten as 3 times 3 times 3 to the negative 2/3 power. Since this is an exponent to an exponent, I can multiply these two together. 3 times negative 2/3 gives me negative 2. 3 to the negative 2 means it's 1 over 3 squared, which is 1 over 9. Okay? All right. And then it just shows you how to do on the TI-84, how do you do a rational exponent like that? You just use the caret here, and then you put in parentheses like negative, use the negative, not the subtract sign. Okay? And that's it for page 5.